Okay, today we are going to discuss about the half subtractor. Okay, and this is the block diagramic representation of the half subtractor. In the short form, I am writing it as the HS, half subtractor, and it have the two inputs which are labeled as AB and two outputs which are labeled as one is difference DIFF and next one is the borrow. Okay, borrow. In short form I am writing it as the D. Next borrow I am writing it as the B. Okay, now in this class we are going to discuss about the how to design the logic diagram for the half subtractor. Okay, and the basic information regarding to the half subtractor is it is a combination circuit which have the two inputs and two outputs. Inputs are labeled as AB, outputs are labeled as difference and borrow. Okay, and what is the capability of this half subtractor, which is going to subtract the two binary bits. Okay, so first I am going to draw the truth table for the half subtractor. Okay, inputs are AB and the outputs are, first output is difference, next output is borrow. Okay, borrow. So this is the truth table of the half subtractor with the two inputs. The possible combinations are 0 0, possible input combinations are 0 0, 0 1, 1 0, 1 1. Okay, you just subtract these two binary bits, 0 minus 0. What is the difference? Difference is 0, and to perform the subtraction between the 0 and 0, is there any borrow required? Not required. That's why put bar is equal to 0. And come to the last input combination 1 1, and between 1 and 1, what is the difference? 0. Is there any is there any borrow required? Not required. Put a 0 and subtract these two. 1 minus 0. Difference is 1. Is there any borrow required? Not required. That's why put a 0. Next one is the subtract 0. Next one is the 0 minus 1. Means subtract 1 minus, subtract 1 from 0. Okay, this is the meaning of 0 minus 1. Subtraction is not possible generally while you are performing the subtraction in the decimal number system. Suppose 27 minus 19. 27 minus 19. Okay, just for understanding purpose. Okay, I am explaining this concept. 7 minus 9. Subtraction is not possible. When the subtraction is not possible, what we are doing? We are taking a borrow from the next position. Okay, and these are the decimal numbers. In the decimal numbers, what about the base value? Base value is the 10. Okay, base value is the 10. That's why. So what is the resultant value? 10 plus 7, 17. 17 minus 9. What is the value of 17 minus 9? 8. 17 minus 9 is the 8. And here we taken a borrow from this position. Then what is the remaining value? 1. 1 minus 1, 0. Okay. You apply the same concept. You apply the same concept in the binary system also. 0 minus 1. Subtraction not is possible? Not possible. 0 minus 1 subtraction not possible. You take a borrow. What is the value of that borrow? What is the weight of that borrow? That weight is the 2. Why? Because these are the binary numbers. Okay, the base is 2. 2 minus 1, that is 1. Difference is 1. So here, after doing the subtraction, the difference value is equal to 1. Okay, to perform the subtraction, is there any borrow required or not? Borrow required. If the borrow is required, you put a 1. Okay, so this is the way to fill the truth table for the half subtractor. Once you constructed the truth table for the half subtractor, then you just try to write the Boolean expression for the two output variables of half subtractor, which are labeled as one is D. D is nothing but the difference. Next one is the B. B is nothing but the borrow. And how to write the Boolean expression? So in the Boolean expression, what we are doing? We are trying to express the Okay, output variables in terms of the input variables. So for the simple combination circuit, which are the output variables? Difference and borrow. Which are the input variables? A and B. Okay, and try to express the D in terms of AB. Try to express the B in terms of A and B. So here to write the Boolean expression, go to the corresponding output column. Wherever ones are present, go to the corresponding input combination. Try to express the input combination in the algebraic form. So therefore this is equal to first combination is the 0 1. Its algebraic notation is A bar B. Next input combination is the 1 0. Its algebraic notation is the AB bar. In the same way, try to write the Boolean expression for the borrow, and here only single 1 is present. Go to the corresponding input combination. That input combination is the 0 and 1, and try to express try to write it in the algebraic form. So this is equal to A bar into B. And whatever the next step, once you return the Boolean expression for the two output variables of the half subtractor, you just try to simplify the Boolean expression. Okay, if the further simplification is not possible, then you realize those Boolean expression using the logic diagram. So here further simplification is not possible. That's why I am realizing these two Boolean expression using the logic diagram. So this is nothing but A XOR B, XOR gate output, A bar B plus AB bar. We know in the unit 1 we already learned about what is the Boolean expression for the XOR gate, A bar B plus AB bar. XOR gate we can be represented as the A XOR B, and this is the A bar into B. You just draw the logic diagram for these two output variables. So here take a 2 input XOR gate AB, output is equal to A XOR B. So here A XOR B is nothing but the difference, D is equal to. Next, to realize this Boolean product term, take one AND gate, its output is equal to product of inputs. So here what is the Boolean expression? A bar into B. Take one NOT gate, okay, and to that NOT gate input is A, output of the NOT gate is A bar, and to the second input of the AND gate, okay, input is from the B signal, and this is B, and output is equal to product of inputs A bar into B, and A bar into B we are calling it as the B. So this is the way to design the logic diagram for the half subtractor. Thank you.